Stop flipping your hair.
Good morning and happy Tuesday. Good morning to Mrs. Natalizio's classes.
Bonjour! 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 Bonjour!
I know that we are splitting videos here. I apologize that I don't dress up and not as much fun as her, but we'll get through as best we can, okay? We're continuing on with the August 2018 Regents exam. Again, you should open up the blank Google slide. Try these problems on your own. So if you haven't tried them on your own yet, you need to pause the video. Try them all on your own first.
Listen to me.
And then watch the video for accuracy. There's also a couple problems in here. I think only one that I'm going to have my class do, but you are going to skip because we're kind of in different spots in the curriculum. So just follow along.
Follow the yellow brick road.
Okay, and again, follow the directions. Make sure that you're taking pictures and uploading them. We are super proud of you guys. You're doing amazing.
Let's count how many times she says so.
So let's look at 9. This is where we left off after Mrs. Natalizio's video yesterday. It says in the diagram below, we have triangle HAR and triangle NTY. Angles H and N are right angles. And look, the triangles are similar. It says if AR is 13 and HR is 12, what is the measure of angle Y? Well, angle Y is over here. Similar triangles have sides that are in proportion, but the angles are congruent. So which angle corresponds or is congruent to angle Y? If you can't see it in the picture, which my students know I never use the picture. I go up to this statement up here. I like this much better. I look, if they want me to know the measure of angle Y, well, I see right off the bat it corresponds with angle R, which means it's congruent to angle R. So if I can find the value of angle R, then angle Y is the same. We're going to use SOHCAHTOA here. So whenever we have right triangles, you have two options. Option 1 is Pythagorean's theorem. Helps us find missing sides. Option 2 is SOHCAHTOA. It helps us find missing sides or missing angles. And again, for my kids, I know we haven't done this yet in class, but we did one last week like this, and it's not too bad. Okay? This is SOHCAHTOA. So I first look. If I'm looking at angle R in this first triangle, I'm going to label my sides. The 12 is adjacent. The 13th is the hypotenuse. A and H is cosine. So ka. Your formula says cosine of your angle. Well, I don't know my angle. It's cosine of angle R is what we're looking for, equals the adjacent side, which is 12, divided by the hypotenuse, which is 13. You're going to take out your graphing calculator or, again, the app in your phone. Make sure first you are in degree mode. Anytime you do SOHCAHTOA, you need to make sure that you're in degree mode. So I'm showing you my mode screen. To find the angle, if you need to write this down because you haven't formally learned it, my guys, again, to find the angle in your calculator, you just hit second. And then you're going to hit the cosine button. And when you do that, I'll show you what happens. If I hit second cosine, remember that cosine -1 pulls up, and all you have to do is type in your fraction of your sides. So 12 divided by 13. So I hit second cosine, 12 divided by 13. I'm going to write it over here. I get 22.6. It wants it to the nearest degree. So angle R is rounded to 23 degrees. And we said in the beginning that angle R and angle Y are congruent. So if angle R is 23 degrees, then angle Y is also 23 degrees. Here we go, off to a good start. Let's erase this and move on. Number 10. My guys, you've done this exact problem. I think Mrs. Natalizio's, you guys have done it as well. But let's look here. It says in the diagram below, we have all these lines, I'm not going to read it to you, are shown such that AN, this guy, is congruent to SC. Which additional statement is sufficient to prove the two triangles are congruent, and it gives you a stipulation by angle, side? Well, let's talk about a couple things. If this was a formal proof, you guys would all say to me, okay, I have one set of sides congruent, and I also know that these two angles are congruent. Why are they congruent? Because they're vertical angles, and all vertical angles are congruent. So if we look at your picture, you have one angle and one side. Well, let's talk about this. If I want to prove them congruent by angle, side, like I just said, you guys have one angle and one side. So what do you need? You need another angle. So let's look at our options here. You've seen that with these geometry multiple choice questions, a lot of times you have to read every single option and eliminate as you go. So option 1 says, if they told us that AS and NC bisect each other, would those triangles be congruent by angle, angle, side? Well, we know a bisector gives us a midpoint.
So if
There's just too many stones to count.
If AS and NC bisect each other, then it's saying that like these guys here are congruent. Let me just start with that piece. If they're congruent, do I have angle, angle, side? No, I have angle, side, side. Or side, side, angle. We know we can't have bad words here, so let's get rid of that. That doesn't work. Let's look too. It says that AS and NC bisect each other. So what if I mark the other side? If K is a midpoint here, does that work for angle, angle, side? Nope. Same scenario as the last one. I have angle, side, side. So that's out. So option 1 is gone. Option 2, K is the midpoint of NC. Isn't that literally what we just did? If K is a midpoint, it's saying these guys are congruent. Does that give me angle, angle, side? Nope. It actually doesn't give me congruent triangles at all. So that's out. Option 3 is saying, what if AS, this guy here, was perpendicular to CN, this guy here? Well, if they're perpendicular, perpendicular lines give you right angles, and right angles are congruent. That's great. But we already know those vertical angles are congruent. So that doesn't help me at all. It's talking about the exact same angles we already have. So that's out. Let's see why option 4 is the correct answer. If AN is parallel to SC, well, parallel lines are going to give you some set of congruent angles probably. Okay, either alternate interior, corresponding, alternate exterior you don't have here, or they would show consecutive interior, supplementary. Well, in this case, you can see the Z. So if I kind of outline like this, I can see, oh, look, those are parallel. Then my alternate interior angles are congruent. And now I have triangles congruent by angle, angle, side.
You did it! Congratulations!
Option 4. So not tough work, but you do have to read it and understand each piece and read it for detail.
One woke up with an attitude.
Angle, angle, side there. Okay. Let's move on. Number 11. Mrs. Natalizio's class, you guys are going to skip this one. So you can either just fast forward the video, or if you are really enjoying me talking, you can continue on. My guys, you are expected to do this. So this says, which equation represents a line that is perpendicular to the line here? Well, we've learned that perpendicular lines have slopes that are negative reciprocals, right? So if I look at the line y equals 2 over 3x plus 1, the slope of this line is 2 over 3. It's the number next to x. So if I want a perpendicular line, the slope would be the negative reciprocal, so negative 3 over 2. So I change the sign and flip the fraction.
How'd you get that?
So I now know that I'm looking for one of these 4 options to have a slope of negative 3 over 2. Option 1 and option 2 are going to be a little bit more work. Can you tell me why? Yes, you're correct, because I have to solve them for y. Let's just glance at option 3 and option 4 and hope and pray that that's one of our answers. So number 3, if I look, my slope of this is positive 3 over 2. Is that the number we want? Nope. It needs to be negative 3 over 2. Option 4 is the slope negative 3 over 2. Nope. The slope is negative 2/3. Both of those are out. So we're going to have to look at option 1 and option 2. So let's look at number 1. You have to solve it for y, just like we did when we were back in algebra. To get y alone, I'm going to subtract 3x. I'm left with 2y equals 12 minus 3x. Divide by 2. I'm left with y equals 6 minus 3 over 2x. Slope of this guy is negative 3 over 2. Is it what we want? Yes. It sure is. It matches identical. Lucky for us, option number 1 worked. If it didn't, well, then option number 2 would be the answer, but I would say also solve it for y and just double check your math to make sure you got it correct. Okay. On to number 12. So this one here, we have two triangles overlapping. Now, my guys, I've told you that I want you to, every single time you have two triangles overlapping, I want you to redraw. It's going to give you similar triangles. Mrs. Natalizio's class, you guys understand how to use the side splitter theorem, so go ahead and do that. But I'm going to read through the problem, and then I'm going to redraw, probably pretty terribly, sorry, and go from there. So 12 says in the diagram of triangle ABC below, points D and E are on the sides AB and CB respectively, such that DE is parallel to AC. They're telling me that because that's showing me that those two triangles are similar. So I'm going to, before I read any further, I'm going to redraw. This will be the big one. We'll call it, it's ACB. I'll do the smaller one, which is DEB. My guys, you're used to my terrible drawings. I apologize to Mrs. Natalizio's class.
Z.
Okay, now I also like to label my redrawn picture and the original. So let's see what it gave me. It says if EB is 3 more than DB, boo, that means you're going to have to add in some variables. Remember the last one that they mentioned is usually going to get the X. So if they say EB is 3 more than DB, I'm going to call DB X. And I'm going to call EB is 3 more than that. So 3 plus X. Okay. It also is telling me, and again, before I actually go any further, I'm going to go over to my little triangles. I have DB is X. EB is 3 more than that. So 3 plus X. So that's what we have in so far. Let's look at the next part. The next part reads AB. This whole guy is 14. And CB, this whole guy is 21. So again, over in this picture, I'm going to have a 14 here and a 21 there. Now, Mrs. Natalizio's class, if you guys want to use the side splitter theorem, feel free. My guys, because these are similar, we're going to set up a proportion and cross multiply. Make sure that we answer the question, which is what is the length of AD? So we'll figure that out in just a second. 2 ways to set up the proportion. I'm going to do 14 over 21 equals X over 3 plus X. You could have done 14 over X equals 21 over 3 plus X as well. When I cross multiply here, I get 21X equals, now this 14 has to be distributed to the 3 and the X. So 14 times 3 is 42 plus 14X. Sorry, I'll rewrite that down here. I have 21X equals 42 plus 14X. I am going to subtract the 14X over to the 21. I get 7X equals 42. Divide by 7. And I'm left with X equals 6. Now look at your answers. You're going to be like, yes, I've done so much work and I'm done. But read it carefully. Did they ask for X? Did they ask for DB? No, they didn't. You just found X, which is this guy here. So you just found that this is 6. They wanted to know the length of AD. How long is it? Well, if the whole thing is 14 and that piece is 6, then this guy is 8. So option 2. Okay, not tough, but you did have to know how to set up the problem and use a decent amount of algebra there. All right, let's look at number 13. And we got a nice picture in here for you. So it says quadrilateral math has pairs of opposite sides congruent and parallel. Which statement about quadrilateral math is always true? Well, down here we drew a little picture, okay, and marked it. So the only information that they've given us is that both sets of sides are both congruent. So see how MH is marked congruent to AT and MA is marked congruent to HT, and that both sets of sides are parallel. So that's all marked in the picture. Well, let's talk about it. If we go back to all of our properties, right? Is this a property? Yes, it's a property of a parallelogram. But is it a property anything more specific? Does it get me a rectangle? Does it get me a rhombus? Does it get me a square? No, this just gets me a parallelogram. It's a property of a parallelogram. So now I have to look at options 1, 2, 3, and 4 and say, okay, which one of these is also just a property of a parallelogram? It can't be a rhombus, a square, or a rectangle, anything more specific. So let's read each one. Option 1 says MT, this guy, sorry, is congruent to AH. If I have a parallelogram, are the diagonals congruent? No, diagonals are congruent for a square and a rectangle. This is just a parallelogram, so option 1 is out. Option 2 says MT, should have kept him in, is perpendicular to AH. Is a property of a parallelogram that the diagonals are perpendicular? No, that's a property of a rhombus and a square. So again, I just have a parallelogram here. Option number 3 says angle MHT, that's this angle here, is congruent to angle ATH, this angle. Are those two angles congruent? Nope. Okay, those two angles are supplementary. That's the property of a parallelogram. So option 3 is out. It has to be option 4, but let's see why. Option 4 says the measure of angle MAT, this guy here, is congruent to measure of angle MHT, this guy here. Well, a property of a parallelogram is opposite angles are congruent. So there we go. That's why that one works. That's just knowing your properties and a little bit of vocab, but kind of tough. We are going to omit questions 14 and 15. Woohoo! And this is number 16. This is the last one for today. So this one says we have triangle ABC, points D and E are on sides AB and BC respectively, such that DE and AC are parallel. And again, the reason they're telling you they're parallel is because when you have overlapping triangles, you're going to get similar triangles. I'm going to redraw. So I have my big guy here, which is triangle ACB. And I have the smaller one here, which is triangle BDE. Now, this one, the side splitter theorem won't work. So Mrs. Natalizio's class, you can't use it for this one. You have to redraw. My guys, you are to redraw every single time. Okay, because that's how we did it. So let's keep going here. All right, so I've got the sides parallel. I redrew. Now look at this. It says AD to DB. The ratio of AD to DB is 3:5. Now again, in Mrs. Natalizio's class, you guys might have done something different. My guys, typically when we have a ratio, we put X next to it, right? So if I look at my drawings, if AD to DB is 3:5, I would say this is like 3X and this is 5X. And then I can think of this whole length as 8X, right? So if I kind of label what I have in the other ones, I have DB as 5X. The 3X isn't part of a triangle, but it gives me that whole AB, which is 8X. Here's where this problem gets super interesting, to say the least. It says DB is 6.3. I want to stop there, okay? Because look, we have DB labeled as 5X. Well, if I know that DB is 6.3, can I then find X?
6.3, can I then find X? 6.3, can I then find X?
So let's stop there in 5X. In other words, if DB, if we labeled it with a 5X, but they tell me that it actually equals 6.3, can I say, well, 5X equals 6.3? Let me divide by 5. And I get that X equals, if I do 6.3 divided by 5, 1.26. Isn't it so much nicer to have lengths instead of having X's? So let me replace these X's with actual lengths here. Well, they told me DB is 6.3. So this is 6.3. We found X to equal 1.26. So if I do 8, I'm going to write it here, times 1.26. Let's see what we get for that length. I get 10.08, so I'm going to erase this 8X for a moment. And again, I have, this is now 10.08. I could find AD if I wanted to, but I don't think I'm going to need it right now. I have my sides in my two triangles, so now I got rid of the X's. That's nice. So I have these two sides. Let's go back and see what else they gave me. So again, I just dealt with the if DB is 6.3, and now it's saying and AC, this bottom here, is 9.4. What is the length of DE? I'm going to use a different variable. You can use X again if you want for DE, but I'm going to call that a Y. I'm also going to give myself a little bit of room, so I'm going to erase over here. And now look, I have two similar triangles, and we know when triangles are similar, your sides are in proportion. So we're going to set up our proportion. I'm going to do 10.08, divided by 6.3 equals 9.4 divided by Y. You could also do 10.08 divided by 9.4 equals 6.3 over Y. Either way, cross multiply, I get 10.08Y equals let me quickly in my calculator type in 9.4 times 6.3, which is 59.22, if I could read. I'm going to divide by 10.08, and I get y equals 5.875. To the nearest tenth, 5.9. Okay, so hopefully this wasn't too bad. This is all that we have for you today. Have a great day. Please email us if you have questions. And again, hope everybody's doing well. See you guys.